In this lecture, we are going to solve the knapsack problem. This is a very famous problem. What is a knapsack problem? You're given a set of some items and you're told that you can pick items from this set, but you're also given a max weight. The total weight of all the items you are dropping into your knapsack or bag must not exceed this maximum weight. This is the only constraint. So you'll be having weight of each item, you'll be having maximum weight, and you'll also be having value of each item. Then, are you going to pick random items from the set? No, you're not. You'll pick items that give you the most profit. So this is the knapsack problem. Then you fill up the knapsack with the items such that it maximizes the profit without exceeding the weight limit. Now there are two famous types of knapsack. 0-1 knapsack and the other one is fractional knapsack. The greedy approach is well suited for fractional knapsack, but it is not a choice for 0-1 knapsack. Let's know these types better. 0-1 knapsack means that you must pick either the complete item from the selection set or you will not pick that item. Taking a fraction of item is not possible. So either one, the complete item, or 0, no item. So now you must have got what fractional knapsack means. In fractional knapsack, you can also pick a fraction of the item into your knapsack. For example, let's say you're having a bunch of flowers as an item. In 0-1 knapsack, you have to pick the complete bunch, whereas in fractional knapsack, you can pick any number of flowers from that bunch. So point here is that we cannot solve 0-1 knapsack with greedy. Because you know the greedy approach, the greedy algorithm has only one shot to complete the optimal solution so that it never goes back and reverses the decision. So we have to go with what we are left at the last selection. We have to make it from that anyhow. That's only when we are allowed to take a fraction from the item. We can't change the previous decisions. So that's why greedy is a good choice for fractional knapsack. And 0-1 knapsack is solved with dynamic programming. Got it? Now let's go ahead and see how we are going to solve the fractional knapsack problem. You're having some items here, and these are the values of those items. And these are the respective weights of these items. The capacity of this knapsack is 50. Let's go ahead and start putting the items in knapsack. We must have maximum profit, remember? So the item with highest profit is the second one, 480. Is it? It's maximum among all, but it's the profit on 12 units of that item. Now see the sixth element. Its value is 405, but its weight is only 5 units. So if we calculate the value per kg or per unit, for the second element, it is 480 divided by 12, which is equals to 40. And for the sixth element, it is 405 divided by 5, which is 81. So the sixth element is giving us more profit than the second element because we have saved space for other valuable items. So we have to carefully choose items as we have weight limit. Similarly, let's calculate the profit per weight ratio for each item. So these are the values we get. So we are going to pick items according to these values per unit. So the very first item that we are going to add into our knapsack is the item number 6. Its price is 405 and weight is 5. Now let's calculate the remaining weight. 50 minus 5, which gives us 45. Now next most valuable item is item number 2 because the profit per weight ratio is 40 for it. So let's pick it. Price is 480 and weight is 12. Now the remaining weight is 33. Now next item with profit per weight ratio 17, it's item number 3, price is 336 and its weight is 16. Now the remaining weight is 17. Okay, now the next item is fifth item, for which the price is 238 and the weight is 14. Now the remaining weight is 3. Now the next largest profit by weight ratio is of item 7. Its ratio is 11 and its price is 121. But its weight is 11 and we can only fit item of 3 units into the knapsack. So we have to go for a fraction this time. So let's get only 3 units of this item 7. This is the fraction we need. Now the weight is 3 units, which gives us 33. And now the remaining weight is 0. So this is how we can solve fractional knapsack problem. Now let's analyze the complexity of fractional knapsack. So the main step that takes time is the sorting of all items by their value by weight ratio in decreasing order, right? So the running time will be time taken in sorting these items. So whatever technique you have used for sorting, that will be the complexity of the algorithm. And the most general and efficient one is n log n. Even if you use built-in functions for sorting, it's gonna take order of n log n time, where n is the total number of items you're sorting. Now, space complexity. We're just having temporary variables to solve the problem. So the complexity will be constant as it's not affected by input size.